Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel and press the bell icon to get the regular updates of my upcoming lectures. In the previous lectures, we have studied about the different types of hybridizations along with their structures. If you all have seen that lectures, then you must remember that I have not told you about the bond angles of the geometries containing the lone pairs. There I have mentioned that we will discuss about it in the V.S.E.P.R theory. So our today's topic of the lecture is the V.S.E.P.R theory, that is valence shell electron pair repulsion theory. And we are going to study its first case, that is comparing repulsions among the lone pairs and the bond pairs. So to study that, let's take three examples. I'm taking the example of methane molecule, that's CH4. Another example that I'm taking is ammonia molecule, that's NH3. And the third example which I'm taking is water molecule, which is H2O. Why I have taken these three examples? Because in these three examples we are having hybridization of central atom to be sp3. In NH3 also the hybridization is sp3, and in case of water also the hybridization is sp3. Now, what's the standard geometry of sp3 hybridization containing all the bond pairs? That's tetrahedral. So here, firstly I am drawing the geometry of CH4 molecule. That's the carbon over here. The first bond of hydrogen at this position, second hydrogen to be at this position, third hydrogen to be at this position, and the fourth hydrogen at this position. Here, in bonds, usually two electrons are involved. So I am marking that's the first electron and the second electron. So we usually called our bond to be bond pairs. And in this case, we are having total of 4 bond pairs. So I am marking here we are having total of 4 bond pairs. Now these bond pairs will repel each other. So the bonds will acquire the position in 3 dimensions with the maximum stability. So the bond angle in this case come out to be 109 degrees and 28 minutes. So I am again mentioning the 4 bond pairs will repel each other, due to which the 4 bonds will acquire the most stable position in 3 dimensions with a bond angle of 109 degrees and 28 minutes. Now let's come to the ammonia molecule. In case of ammonia, the central atom is nitrogen and central atom is having one lone pair of electron and it is having 3 bond pair of electrons. So these are the 3 bond pairs. So I am mentioning here we are having one lone pair of electron and 3 bond pair of electron. Now, whenever the tetrahedral geometry is having one lone pair, we have to ignore that lone pair while naming the geometry. So in case of NH3, the name of geometry will be called as pyramidal, not the tetrahedral. So in this case, one unique thing will happen. And what's that? Here, just imagine now diagram in 3 dimensions. Here what's gonna happen? This lone pair of electron is going to repel this bond pair of electron more strongly than repulsive forces between the bond pair and the bond pair. So this lone pair is also repelling this bond pair also, and this lone pair is again repelling this bond pair also, which will result in the shrinkage of bond angle. So what's gonna happen? Here the shrinkage of bond angle will take place. That means the bond angle will decrease from the standard value of 109 degrees and 28 minutes to the 107 degrees. So in this case, one thing is proved, and that thing is the magnitude. I am writing the magnitude of lone pair, bond pair, repulsions is greater than or more than the magnitude of magnitude of bond pair repulsions. Now let's talk about the water molecule. In water molecule, again we are having hybridization to be sp3. So here the central atom is oxygen. The oxygen atom is having 2 lone pair of electrons. So that's the first lone pair of electron, and that's the second lone pair of electrons, and there will be the 2 bond pair of electrons. Hold on. And we are left with 2 bond pair of electrons. So I am again mentioning that in this case we are having 2 lone pairs and 2 bond pairs. Whenever the sp3 hybridization is having the 2 lone pairs and the 2 bond pairs, then the name of geometry of that sp3 hybridization will be called as V shape. So the name of the geometry of water molecule containing 2 lone pairs will be V shape, or its another name is bent shape. So here also one unique thing will happen, and that is these 2 lone pairs of electrons will repel each other very strongly, which will result in the increased repulsion of lone pair with the bond pairs, due to which what's gonna happen? There will be the shrinkage of bond angle. There will be the shrinkage of bond angle even more than the NH3. So here the bond angle will decrease from 109 degrees and 28 minutes to the 104 degrees. So from this point, again one thing is proved, that the magnitude of lone pair repulsions, magnitude of lone pair repulsions are even greater than the magnitude of lone pair bond pair repulsions. So that's the case number 1 of the Vsepr theory, which states that the magnitude of lone pair repulsions is greater than the magnitude of lone pair bond pair repulsions, which is further greater than the magnitude of bond pair repulsions. Due to which, what's gonna happen? Due to which the bond angle in case of lone pair repulsions will be the minimum, and the magnitude of bond pair repulsion is the least. So the here bond angle, bond angle will be maximum. Here I am repeating it again, that the magnitude of lone pair repulsions is the maximum, due to which the value of bond angle, the bond angle will be minimum. So that's all about the case number 1. If the magnitude of lone pair repulsion is the maximum, then the bond angle will be the minimum. There will be the more shrinkage of the bond angle. And in case of bond pair repulsions, which is having the least magnitude, due to which the bond angle will be the maximum, and all the bonds will arrange themselves in the most stable position with a bond angle of 109 degrees and 28 minutes in case of methane molecule. And ammonia, it's having one lone pair, so the bond angle of ammonia will be intermediate to that of the methane molecule and that of the water molecule. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Stay blessed.